Hello.
Yeah.
Yeah. So if you are seeing this one, and I'm having two gates which are connected in that. Actually, you just assume that here inside that two input and two output, and the two inputs are common for both the gates inside that box. I mean, you can assume that inside here it is a NAND and NOR gates. So in that case, what I am
Okay.
doing means. Um, so module and with gate, and my output will be S1 comma S2, and inputs will be A comma B, and here the input is A and B, and the output is S1 comma S2. And now I have to use a NAND and NOR. So NAND S1 comma A comma B, and NOR S2 comma A comma B, and module. Now I am going to instantiate the same module for replicating the all the outputs here. So you may say it is
Okay.
M1 and M2, M3 and M4. So module example instantiations, and my input will be x comma y, and my output will be some r and s, and input x comma y, and the output r comma s. Yeah.
Yes.
Then here what we want to do means you have to call the tut underscore gate. So tut underscore gate m1, and m1 is the instantiation name, and the input and output order will be, initially it is having output S1 and S2, and follow that you are having the input A and B. So here
Yeah.
I have to use the output some W1 comma W2, and the inputs are X comma Y.
Right.
Yeah, and this is M2, and here the output is that means this output is will be come to the next gate. So we may say this is
Input.
M1
Yeah.
and this is M2, and W3 comma W4 comma W1 comma W2.
W. Yeah.
Yeah,
That
and
output is this, right?
yeah, W3 and W4 is the output of M2 block. We may say this one, and this is the input of this one. So and M3 and W5 comma W6, and W3 comma W4 is a
Input.
yeah, and so gate M4, and that
W3. No, no, no.
no, R comma S is your output.
Okay. Yeah, this is the final one. Yeah.
Yeah, and then W5 and W6 are the inputs of the gates and in module. So in this way we are instantiating different modules. So So here actually I instantiated different modules on the same Verilog file. So we may use a different Verilog files or same Verilog file for different modules. Because here we are using
dot v is the common thing that we should be.
yeah, because it's a Verilog file. Yeah, so the extension must be in .v.
So we need to use the Notepad++, or we can use any tool like
text editor.
Word.
Yeah, any text editor is enough.
Okay.
The formatting is simple for Notepad++. If you are seeing that the commands and default keywords are highlighted in blue color, and the remaining things are used in a normal black colors. So for that only I'm using that.
Notepad++.
Yeah, Notepad++.
Okay, if we save it with .v, then we can open it directly in the file folder.
Yeah. Next, we have to create a project. So did you install that software, Xilinx?
That's not working for us. Actually, I had another.
Yeah. Hello.
Can you show us how to start? Yeah.
And
yeah, we got yeah.
Okay.
The Xilinx other one VMware is the same window, showing the same window what you are showing now. So how to create a new?
First, initially close all the projects. Then, if any of the previous projects are open, means that modules also instantiated on the same files. So
No, I closed everything.
yeah, you have to close that project directly. Then choose file, new project. Then just copy that directly where we saved the file. So
okay.
and let put the name of your project. You may say some example one.
Okay.
Then do the next.
Yeah, what we need to do, like from the top, no specifications. Yeah, and it's -3 for me. Is that fine?
That's not a problem. Actually, this is a board specification, and that means for synthesis. In many institutions, they are having Spartan 3, 3, Spartan 6, and Vertex series boards. And in some of the companies also, they are having their own boards. So that's not an issue. For we are just analyzing our design. So in that case, you may choose any of the boards. So in that, you are having multiple boards are there. And
so I choose like non-specified product category all, automotive Spartan 6, XA6L, X4, and some other things.
No. You just choose the evaluation development board. In that, just choose the Spartan 6 SP6001 evaluation platform.
Spartan SP601 evaluation platform.
Yeah, that one.
Okay.
So the remaining will be automatically set.
Yeah. Now it went down. Yeah.
Only you have
in
to.
The bottom.
In the bottom.
Yeah, it is the same thing, sir.
Okay.
The simulator is like Model Sim SC mixed. Should I change it also?
Yeah, definitely. Actually, here you are having a default simulator, that's iSim. So you don't want to change anything here, because when instantiating any modules inside the Xilinx and Xilinx, then it is difficult to use the external simulator, because once yeah.
Should I change it over here to the same thing as we were having over there?
Yeah, you just choose the iSim simulator.
I got it. No.
No,
Yeah.
Yeah.
I got it. Preferred language, Verilog. Yep, that's the same thing.
Only you have to see this one, either Verilog or VHA. In that you have to choose the Verilog.
Your voice is low.
Hey, hello.
Yeah, now fine.
Now it is clear.
Yeah, you were saying something.
Yeah, your preferred language must be Verilog because we are going to write the
Yeah.
program in Verilog, so that only you have to see clearly before
Okay.
making anything. Okay. So next, afterwards, the remaining are in default. So you just choose next, and which is a summary of our board and language what we have preferred. So that summary will be shown, and afterwards you have to click the finish.
Okay.
And now you are having a project empty view. Then afterwards you have to choose project new source.
Just a second. I didn't.
Yeah, fine.
Yeah. Project
New source.
new source.
Yeah.
Okay.
Then you have to choose the Verilog module.
Verilog module. Okay.
Yeah. Then for that module we have just named some any project names you just given, either example or something else for your Verilog file.
Okay. I can give the same name, right? Example.
Example whatever it may be. That's your user defined
Okay.
name. That's all.
Okay. I mean, I
And
was asking the location and the other one. Can it match or not?
no, 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 not like that.
Okay.
That is not.
Should match.
Yeah.
Okay.
And here we already created a project. In that case, you don't want to use anything. You just next and finish, and afterwards you just copy and paste. In case if you are creating means what you have to do means you just define the input and output here. So for example, here I am choosing A as my input and B as my input and S as my output. And here if it is a one bit means you have to use a single input and output. If it is a multiple means then you have to use a buses, and the buses will be 8-bit wide, so 7 to 0. And here which is also 7 to 0, and the SS will be 8 to 0. So next, finish. So afterwards, if you are seeing that your module, which consists of a module and the corresponding inputs and output connections are there. So in that we created totally the input A and B of 8-bit wide, and the output S will be of 9-bit wide. So in this way it is created. Afterwards you have to just the functionality only you have to define inside the module. That's all.
Okay.
So here we already wrote a program, so we just copy and paste that program around. Just delete all the things, and so
Okay.
if you are having any error message, it will show in the console window. So afterwards, just synthesize that module.
Next is synthesis, right?
Yeah. Next is synthesizing.
Synthesis.
Just double click that synthesis icon. That's all.
Okay.
And if you click that plus symbol near to that synthesize, you are having number of options are there. That is view RTL schematic, technology schematic, then checks input,
Yeah.
then generate position. So in that you just see your RTL module, RTL schematic, and
Okay.
if you're seeing that it will create a number of instantiations based on the first module, that is TOT underscore gate. So in that what we given means M1, M2, M3, M4. So in that all the gates are sequentially connected. So in that way, and if you open that module, it will create an AND and NOR logics.
Okay.
Okay. You just create a simple module, some AND or any of the logic gates, then see whether it is working or not.
Yeah. Just give me a second. I will just.
Yeah. I will
Try.
wait. No problem.
మొత్తం ఫిల్ చేయకు అది మాడ్యూల్ ఇది పెట్టాను కదా పేరు అక్కడ రాయ్ That token. S comma ABC, A comma B comma C. Enter. Input A comma B comma C. Output as sir. Assign S is equal to space A small error ampersand type B ampersand type C. Watching that? And module. And in module. In module I'm looking at. Now we go to synthesize, right?
Yeah, you just synthesize that.
Synthesize view. I'm not getting the down bar. Is there any other thing to?
Which means?
The down bar which is showing errors, right? That one I'm not able to get it.
In the console.
Console.
Yeah.
So. View RTL schematic. Running on, still running. Console. Console.
What kind of error is shown?
No, it isn't showing any error. It's running still, but I'm not able to get that console thing.
In that layout, you just choose a load default layout.
Layout, default layout.
Load default layout.
Yeah.
Now you are showing the default layout of your Xilinx AC, and in that you are having all the tabs are there.
Yeah, it says running SST command line.
Yeah, it will
something and reading design.
Fine.
So after synthesize, we can see the RTL model, or we can view the RTL model before it.
No. After synthesizing only, you are able to view the RTL schematic.
Okay.
Yeah, before that it is not possible to see the RTL schematic, because after synthesizing only we are getting the actual mapping between your gate and netlist.
Okay. It's still running.
Okay. Or else you have to do one thing. You just again choose the synthesis and right click on that. Just stop that and rerun again.
Okay. Yeah, it's elaborating. Now it's elaborating.
Okay, elaborating means it will continually. That means the synthesis will continue, so not a problem. But if still stuck on that line means you just do that.
Optimizing. Okay, now it changed.
Okay.
Optimizing the unit.
Then no problem. It will synthesize.
Successful.
Okay, fine. Now view the RTL schematic whether your gates are correctly mapped.
Oh, I just did only the okay. Now it asked me start with an Explorer wizard or start with schematic of top level block.
Start with schematic of top level block. Choose that one and don't show that message again. You just click on that option and click OK.
No. Yeah.
Fine.
Yeah, we got the same thing.
Okay, fine. Next we
Yeah,
have to.
we did for and 3 input and.
Okay, fine. Next, you just do the simulation because if the synthesis is okay, we must check the functionality of our design. So for that, you just choose a simulation, then choose your module name.
Where? Can you show us one more time?
Yeah, just choose a simulation in which is nearer to
Yeah,
the implementation. You choose that and choose your
and
module name. If you are choosing this board name, it will won't. That means it won't get the simulation option. So you just choose the
now it.
yeah project file. Next, then in that plus icon, if you are clicking means and you are getting two options, that is behavioral check syntax and simulate behavioral model. In that choose behavioral check
Yeah.
syntax, and afterwards
Sim-
choose the simulate behavioral
I'm
model.
sorry.
Yeah,
Okay, choose simulate behavior model.
yes, choose simulate behavioral model. So in that case, if you are seeing that error simulator 861 file to link the design, then choose a 64-bit project navigator, because Windows 8 and 10 which is having different issues on Xilinx software.
Okay, it's just running the simulation elaboration something.
Okay, then if it's fine, no problem.
Yeah, I think I won't have the problem because I'm using this virtual machine, right? And it's operating on
Okay,
Linux.
okay, then no problem. Then choose the simulation.
Okay, so
Did you get that window?
process. Which one?
That
This
simulator
one,
window?
no.
You are getting a separate window for simulator window like that after elaborating.
Okay, no, I didn't get any separate window over here.
Whether in that console, whether you are having any errors, you just check it that.
It's a, it's like double clicking or single click on it.
Double clicking,
Okay.
or
Yeah.
else
Yeah, we got the
right click and do the rerun all process.
where? Same.
Right click on that and do the rerun all. This one, just right click it. This one, that is the blade behavioral model. In that you are having option rerun all. You just choose that.
It's saying it's elaborating.
Yeah. After elaborating, you will show see the window actually like that.
Yeah, it's not done yet. It's
Okay.
taking some. Now we got a graphical
Yeah, that's
view.
one.
Now we need to give the force inputs, right?
Yeah, you
Force.
have to force the inputs and you have to run that simulation means you will get the output.
So we got two. Yeah, we have done two times. We are getting for this.
Okay. Actually, we know the three input and. So in that,
Yeah.
if any of the inputs are zero, then the output will be zero. If all the inputs are one, then only the output will be one. So in that case, we just see the major combinations.
Mhm.
So if I didn't give any inputs to the any of the input, then it will automatically turn into don't care condition. So my
Mhm.
output will also be in don't care condition.
So where I should give the force inputs?
Yeah, I
Right
will
click.
show it. Wait a minute.
Force constant.
Yeah, force constant. That only.
Force to value will give 0 and 1.
Force constant, and in that force to value, you have to choose a 0 or 1. This time offset is after 50 nanosecond or 100 nanosecond. If I specify the time, then automatically after that particular value, the constant value will be set. That's why that time offset and cancel time offset, starting and timing.
Okay.
And you just how many inputs are
1.
there, you just choose all the inputs.
Okay.
Afterwards, the
Then what we need to do after giving the forced input?
run for the time specified on the toolbar. You are having option on the top right hand side. You just see that mouse arrow which is shown here. You are having a timing option. Okay,
Yeah.
here I choose a 1 microsecond, and near to that you are having a run for a specified time. You just choose that.
Okay.
Yeah.
Just a sec. 1 microsecond ఉంది రన్ ఎక్కడ ఉందిరా ఆ పక్కన కదా ఇదా
And
yeah, this is one.
Yeah.
One. It's all green lines, yeah, green straight lines for us.
If it is red or blue, state which indicates a don't care condition, and if it is blue, that is a high impedance state. That
We are not hearing. We are unable to hear you.
Hello.
Yeah.
Actually, if it is a red line, that is a indication of don't care in the output window. And if it is a blue color line, then it is a high impedance state. If it is a green, then you are having either 0 or 1 state.
Okay.
So, and you are having the values here, and if you are having doubt, means you just see that value x and y are 1, and my output r and s is also 1. So in the intermediate signal, w and w2 are 0.
Yeah.
So 0 is like that, and 1 is like that shaded portion.
Okay.
So next, for your same program, you just try to write the test bench, because whenever you are going to write a Verilog module, you are also able to write the test bench to simulate that module. So you just
end this up.
Yeah,
Close this window.
Yeah, you just simulate, close the simulator window. Then after that, choose the module name in your project navigator.
Okay.
Then choose the right click on that, and choose a new source.
New source.
And in that, you just choose the Verilog test fixture.
Verilog
test fixture. Yeah, in that you just type your test bench name. Here I am using TB. In default, most of the programs which contains a test bench or TB, that indicates a test bench of your corresponding module.
Okay. Test bench. We need to give a new name, right?
Yeah, that's a new name. That is different from your module name. So that's why I'm choosing here as a TB. Next, just next. Then in that, here I'm having multiple modules, so I have to choose the one among the top module. So the module name will be example underscore inst. So this is my top module, so you have to choose the example underscore inst. But you are having only a single module, so you just choose that module and press the next.
Finish.
Yeah. Then afterwards, you are having a number of lines are there. In that, in the module, you are not having any module instantiations. That means module name, and there is no port connections, because all the inputs are declared as register, and all the outputs are declared as wire. This is the basics in test bench writing.
Yeah.
And afterwards, you are seeing the instantiation of your module. So inside that, you are having the x is allocated to x and y is allocated to y. And in your programming, in which that means which input is given to that, actually the same variable will be assigned to the instantiation module. So
yeah, I did.
Then afterwards, initially my input will be x is 0 and y is 0. So after 100 nanosecond, I am changing the value.
We haven't got initial, begin, all that. No, we got it.
No,
Yeah,
in that
yeah,
you are
yeah.
having module. Yeah, initial begin in the
Yeah.
sense that's like all set statement we are having now in the behavioral modeling.
Okay.
In the same thing, actually, for a hardware purpose, we are using that always set. But in the software running, you are not need to wait for that much amount of time. Actually, all the inputs are given in parallelly. So in that case, we are using that initial and end. Initial
Okay.
begin end. So for a concurrent simulation, we are using initial, begin, and end. But for hardware simulation, hardware synthesis, we are using that always set statement. But almost both are same.
Okay.
So x equal to here 0, sorry 1, and put the semicolon. For your inputs, you just given input. It's a single
Okay.
bit one.
A.
So, if you are
Yeah.
having three inputs means just after A, B, C, after 100 nanosecond, assign a value for B or C, and A will be default in 0. Then after 100 nanosecond, you just assign a value for A. Likewise, you just choose some multiple values.
For three inputs.
Yeah, for three inputs. Because you must analyze all the combinations. So three inputs means 2 per 3, 8 combination you must do. That means 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1.
Over here.
What?
Can we write any formula like? Can we give a statement to put all these things together?
Uh, you are having three inputs. Is that so? So like that you
Yeah.
just write. Like that. That means initially you are having three inputs. So A equal to 0, then semicolon, B equal to 0, semicolon, C is equal to 0. So this is the initial statement. So afterwards, after 100 nanoseconds, you are having three inputs A, B, C. So these
Yeah.
three inputs are one bit wide. So one bit wide in
Okay.
the sense I am having 2 power 3 combinations. So totally 8 outputs.
Eight.
That
Yeah.
so from 000 to 111. That means 000 to A 7. So
Yeah.
A equal to 0, B equal
Oh, we
to
have to give all the
yeah,
combinations
yeah,
here.
yeah. That's what I'm saying. Because in
Mm-hmm.
the manual simulation, you have to dump every values. So, but in the case of writing, it is easy to declare that value. That's why we are preferring the test bench.
Okay.
So A is equal to 0,
So
B is
after
equal,
the first one, like B equal to 0 and C equal to 0.
C is equal to 1.
Okay.
Likewise, you have to give all the values. So after 100
Hash 100.
nanosecond, yeah, hash converter is
Yeah.
a 100 nanosecond or 100 time unit delay.
Slow.
A equal to 0, B equal to 1, and C equal to 0. Then after
0. Yeah.
yeah, after 100 nanosecond delay,
One
A
zero zero.
yeah 1001, no 001, 011. B is equal to
0 1.
yeah 1,
Yeah.
and C is equal to
Is
1.
it in a particular order or we can change the order?
We can change the order. That's not a problem.
Okay.
That's your own order. So you just choose any of the four values,
Hmm.
and afterwards you just come save that module and run the simulation again.
Okay.
Now after 100 nanosecond delay, hash.
Oh, I'm sorry, I didn't see. Then what we need to do after giving the values?
After giving the values, you just save that file. Then choose the TB.
Okay. Save that file.
Yeah, save that file and choose the TB, and again choose the simulate behavioral model. Right click on that and rerun all.
The file and then save.
File and save.
Yeah. Okay.
Then afterwards choose that test bench name in your project
And the simulate.
hierarchy, and simulate that behavioral model.
Okay.
So if you are simulating means you are getting a simulator window.
Yeah, it's taking some time.
Okay, no problem.
అయిపోయిందిరా ఇంత కూడా అంతే మళ్ళీ వచ్చింది It's saying no process is running after it ran for some time.
No process is running. That choose that simulate behavioral model, and in that choose the rerun all, not run.
Okay, right click. Running. Rerun all run.
Yeah, rerun all.
Yeah, it's taking some time.
Yeah, okay, no problem, fine. Whether it is elaborating?
Yeah, we got a new window, but
Okay.
it's not showing.
Fine. It will take time sometimes.
Unable to execute live simulation.
Unable to. You just close the previous simulator window.
Okay. I think
And
that's the problem.
if any of the simulator windows are open, means you just close that. Actually, there's a possibility to do only one simulations at a time.
Okay.
And afterwards do the same thing. That means simulate it.
Rerun all, right?
Yeah, rerun all.
No, it should come, I think.
Okay.
We got the same thing, unable to execute the live simulation command.
Unable to execute the simulation command.
Actually, it's saying like fail to communicate with
Simulator.
child process. Yeah, child process, and it's saying please shut down ISIM and retry the simulation. Is the problem?
So you just
Time
close
resolution.
the project navigator and iSIM simulator completely. Then restart that.
Close the entire thing.
Close the entire project navigator as well as simulator.
No, actually, I think it's because we are pressing it 2 times.
And if it is that condition means at least it will one window will be open.
Yeah, actually the other window popped up right now.
Okay, fine. Yeah, you just close and open it again means it will definitely open because you already got a simulator window while forcing. So if you are having any error in the program means then it will show which line contains error.
Okay. Mhm. Now it's saying no process running.
No process
We
running.
haven't got any
The
window.
code.
Yeah. Yeah, we got it. We got the window now. Yeah, now it's coming elaborating.
Uh, After elaboration, you will see
Creating
the output.
database. Yeah. Yeah, we got.
So in this way
But
only showing
it's showing all straight lines for us. That
all
green
straight
is
lines,
not moving at all. Yeah.
all straight lines. So which one you choose to simulate it, whether it's a TB or the module?
The TB itself.
The
TB,
TB,
yeah.
then it will automatically the output will come.
I mean, only one set of output is coming. So is it like
One set of output in the sense.
100 only is coming?
So did you give the delay?
Yeah. #100, right? Yeah.
Yeah, hash and right. Yes, that's. You just send me that instantiation module in the tax in that chat. You just copy and paste it here. That code.
Okay.
For 100, also you are not getting output,
100, we are getting output 000.
but remaining outputs are not shown.
Yeah. Yeah.
Okay, fine. Mm.
So if you simulate this, can you once simulate this one for us?
Yeah, fine. Just send it to me, or else I will create it. No problem.
It's coming only for the last one. A is equal to 100, A equal to 1, B equal to 0, C equal to 0.
Okay, fine. No problem. I will create it. No problem. Module. Uh,
Yeah, just give me a sec. Just give me a second.
okay,
We'll
fine.
send you.
Uh,
I'm logging from my computer. And send you.
okay. It's okay. I will wait.
Mm. Send the whole code?
Yeah, in the test bench itself.
Yeah. Test bench itself. Yeah,
Yeah.
we'll send.
సైన్ చేయలేదు.
సైన్ ఇన్ నేను అవ్వాల. అది కాపీ చేసి నాకు మెయిల్ పెట్టు. He is unable to log in.
In the chat, alone just that.
Yeah, I'm trying to join the.
Okay, fine.
It's asking me to. ఇంత వచ్చింది.
Yeah.
No.
No, పంపి మెయిల్లో. రాసి పంపిరు, నోట్ ప్యాడ్ ఇస్తే నేను యాడ్ పంపినరు. మళ్ళీ డైరెక్ట్ మెయిల్లో కొట్టది, అది ఈజీ.
దేంట్లో
భగీరథ ఒకటే ఉన్నది కింద, సబ్జెక్ట్ కాదు.
So is that your Testbench, right?
Yeah.
So actually,
Oh no.
Okay, it's an AND gate. So ABC and my output is S1. So NAND of S1 A, B, C, and it's a 3-input NAND gate. So for that I wrote a test cases for all the combinations. That means 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Just
I am sending the code. Can you check it?
Okay, fine.
Yeah. Did you got the code?
Yeah, I got it.
Yes, everything.
It's a correct one. No problem.
Is that code correct?
Yeah, code is correct. And here you are having zoom all option is there. You just choose that.
Okay.
I think that's
Mhm.
issue.
In the simulator.
In the simulator, you are having zoom all option is there.
For us, it's not starting from
Zoom to full. Yeah,
zoom to full. Just choose that.
Yeah.
Now you are showing seeing all the output.
Yeah. But for us, the time scale is not starting from 0 nanoseconds.
No.
To
This is the time scale. I think we can do this also.
No, the simulation automatically started only from 0 nanosecond.
Yeah, it starts from 0 nanosecond, but got the white lines every 200 nanoseconds.
200 nanoseconds, you are getting white line.
Yeah, we haven't got
I didn't got the scaling thing.
For
100. ఇక్కడ చూపిస్తుంది చూడు, ఆ పైన ఆప్షన్ ఇస్ పైన వైట్ కలర్.
Yes.
Okay, cool.
TUT underscore UT.
Yeah, we got it now.
Now you got it.
Yeah.
Okay, fine. So this is not an issue on your code, actually.
Yeah.
Yeah.
So for the same code you send, I just
Okay.
so now you are seeing that output for your inputs.
Yeah. Yeah.
Yeah, fine. So in this way only we are creating and simulating and synthesizing our modules.
Okay.
Yeah, next one is a Verilog primitives. So primitives are predefined logic gates, and which
I
is
mean,
yeah, and you are having another option which is a user defined primitives. But whenever you are writing the user defined primitives, it must have only one output, and you may have a number of inputs.
Okay.
And all the predefined primitives are combination one, and which is of a type net. That means which is a wire.
Wire. Okay.
Yeah, and the inputs of primitive can be of any type, whether it is a register or net variable. And
Wire means like internal
yeah,
connections, right?
internal connections. Yeah.
I
So
mean, if the
uh,
we have an NAND gate, but we used for one input we use NOT gate. Then
yeah,
the wire NOT gate and NAND gate is the
yeah,
wire.
yeah.
Yeah.
Likewise, because all the functionalities are predefined one, so we don't want to create
Okay.
anything like that. So that's why we are saying that it's a primitive.
Mm-hmm.
And it support the UDP, that means user defined primitive, it supports both combination and sequential. But in the case of predefined primitives, we are not having any sequential circuit, which is purely a combination circuit one.
Mm-hmm.
That is your basic logic gates alone. And then you are having a four value
Okay.
logic that has been used inside the Verilog. So that means level 0, level 1, and the unknown state as well as the high impedance state.
High impedance state.
Yeah.
Yeah.
The high impedance state is used only inside the tri-state gates.
Mm-hmm.
So the tri-state gates are nothing but a buffer. That means tri-state
Mm.
buffer. Then tri-state inverter. So in that you are having a control line, and if it is 0, then the output will be automatically disconnected from the input, and if it is 1, then the output will be automatically connected to the input. That's actually a tri-state buffer.
Okay.
So So tri-state gates are in a high impedance state, but in your real logic value, we are not having any high impedance state. The
Okay.
except condition is if we are using the tri-state logic, then only you are getting the output of high impedance state, that is Z. But in the case of normal logic, you are not that means you are not getting any output in high impedance state.
Okay.
So if I'm using that multi-value logic, and if you're seeing a NAND gate, the truth table will be like that. That means if the values are 0 and 1, then the output will be either 0 0 or 1 1. And in the case of X for NAND, so if it is multiplied with any value, then the output will
X
be X means don't
unknown logic.
unknown or don't get logic.
Okay.
And in the case of Z, the output will be Z only.
Okay. It's the
Uh,
same, yeah.
yeah. Next one is a delay. So if you want to specify any delay inside that, so you have to use a NAND hash of 1. That means 1 unit delay of a NAND gate. And you are having 3 logic gates are connected here, G1, G2, G3 of 3 gates. And these 3 gates are NAND gates alone.
Mm-hmm.
And next one is a rising and falling delay. So SPEC param, that means spec param is the default keyword to specify the parameter value. Yes.
Spec param.
Yeah. Or else we are using that term parameter
Okay.
for
This is for
defining the
rising delay.
constant. Yeah. For writing the constant value.
I mean, spec param is for rising delay or falling delay.
Spec param is
Okay.
specifying the parameter value. That's all. That's to specify the constant value.
Okay. Okay.
So in that you are having the propagation delay from 0 to 1. Then you are having a 1.13 nanosecond to 3.09, then to 7.75. That's a minimum delay and a typical delay and maximum delay of a timing parameter. And 1 to 0 transition, you are having 0.93, 2.5 and 7.35. So these three values are a minimum, typical and maximum delay of that timing parameter. And next one is here
In
these
that,
kind of parameters are used only in the synthesizable tools. That means the cadence. In that only we are specifying these kind of informations. But in the
yeah,
case of yeah, say
previous slide.
previous slide.
Yeah. In this, which one is the rising delay and which one is the falling delay?
Actually, rising delay in the sense 1.13 to 3.09 because it's a 0 1
Okay.
transition, 0 to 1 transition.
Oh,
So that delay
okay.
will be the difference between these two values, and the falling delay will
Okay.
be 0.09. That means 3.09 to 7.7. That means for the total clock pulse.
Okay.
Okay, yeah. And
Mm-hmm.
these kind of informations only where we are specifying in the sense the ASIC cell library. That means you are
Mm-hmm.
having a primitive cells, and in that I have to use that value for A and B of different inputs. So in that case only
Okay.
we are specifying that specify spec parameter, and we are mentioning the timing delay parameters
Mm-hmm.
for semi-custom ASIC design. But we are purely seeing inside the FPGA, we are not able to do that. That means we are not using that timing parameter value, and which will default to one only it will take.
Okay.
Uh,
We can't use this
yeah, we
in
can't use it.
Xilinx.
We can't use inside the Xilinx or models in simulators
Okay.
because which is a ASIC cell library, which is a complete different one. But in the case of FPGA and CPLs, which is also a different one.
Mm.
And in the ASIC cell libraries, you are having module names like that. NAND F201, which is a 2 input and 1 input NAND gate, NAND functionality, and you are having O as output, and A1 and B1 are inputs. So
Okay.
likewise, you have to specify. And if you are seeing that next example, which is also the similar to your NAND, that means ASIC library implementation. So in that you are having XOR function, and in that you are having 2 input and 1 output. And G1 it is having a sum is output and A and B as an inputs. And NAND gate of function, two input of one, and two input and one output of C bar as our output, and A and B as an input. And for inverter function, you are having 101. That means one input and one output.
Yeah.
So you are having a two types of structural descriptions are there. There is a explicit structural and implicit structural. So in that case, it is a explicit structural description. So in the case of continuous assignment, that's an implicit structural description. That means using assign statement. So in that case, if you are seeing
Okay.
assign y equal to a or b, so this is an implicit structural modeling. So if you are assigning, that means if you are writing the Boolean expression using the keyword assign, then it automatically assigns the logic gate to the particular functionality. But in that case, if you are seeing here, you are having input and output of 7-bit wide, sorry, 8-bit wide.
8-bit wide, yeah.
And it will create a 8-bit OR logic, not a single bit gate. But you wrote assignment of a single statement.
What is that A by B? That means A or B? Yeah. Okay.
A or B, which is a OR logic.
Mm-hmm.
And in the same example, you just write a code for the same program, for this program, and see the output. You just write your own self.
Do you want us to write this program?
Yeah. No, you just write the program in Xilinx and execute the output and show the RTL schematic. That means you just see the RTL schematic and how it will shown.
Okay.
Because it is a 8-bit wide inputs and 8-bit wide output. But you wrote a single statement y equal to A or B.
A or B.
Yeah.
We need to create a new project, right?
Yeah. Or else you just delete that Verilog, that means Verilog lines in that file, and you just or command it.
Okay, after end module, can we comment it?
Yeah, you just command it. Inside that you just write your same module, because creating means which is also taking just little much time now. So you just command it, and down that you just write your that code.
Yeah. Can you show us? Oh, yeah.
Yeah.
Module
underscore
or
open braces.
Y
comma A comma B, close braces. Semicolon.
B and input.
Open square bracket. 7:0. Close bracket. A comma B. A comma B.
Comma B.
Enter. Output. Chapter open square bracket. 7:0. Y. Close bracket. C.
Then
assign y equal to A. Yeah. No, shift. No. B. Exclamation mark. And module. So only the top one, right?
Yeah, only the top one, because that's the next one.
Okay.
Another module, which is a different one.
And see.
This is RTF schematic. Save it. And
yeah. Why TV जाएगा test?
हाँ, नको बजा. Simulate behavior modeling, right?
Yeah, simulate behavioral model, and not simulation. So the implementation.
Okay.
Synthesis.
Implementation.
Okay.
Synthesis.
View RTL logic.
No. Synthesize first.
Synthesize it.
If you are choosing the
Double click.
larger schematic, it will automatically synthesize it. So it's also the same thing.
I mean, like it's the previous one, right? So it is showing by default. So I'm just synthesizing again.
Yeah.
Return automatically. Yes. Yes. Run failed synthesis.
Run failed. You just write it and do the rerun all. Not run.
Mali rerun all what? రావట్లేదు ఇంప్లిమెంటేషన్ లోనే ఉంది ఇంప్లిమెంటేషన్ లోనే ఇది అదే ఆ పైన దగ్గర ఉంది ఇదిగో పైన సెలెక్ట్ చేయాల్సింది కింద సెలెక్ట్ చేయాలి టీవీ అని చెక్ సింథసిస్ చెక్ సింటాక్స్ దట్ వన్ ఇక్కడ డిజైన్ యూటిలిటీస్ ప్లస్ it's not showing. I mean, we wrote it in a test bench, so is it not?
No. If it is a test bench, means definitely it will not shown in the implementation.
We have written in tut.v only, that file only.
Which one? Whether it's a design file or a simulation file?
Design file only.
Design file. Then it will correctly synthesized. Actually, what is the
We
error
need to
you got?
The top model was not been specified. This can happen if no sources have been added. Oh, yeah.
Then that one will be deleted from your project directory, I think. That module.
Okay.
Or else choose another thing. Just right click on it, new source, and choose a Verilog module, and you just name it some.
Wait, one more time. Sorry.
Okay, fine. You just project, new source.
Project.
New source.
Yeah.
And choose a Verilog module.
Verilog module.
Yeah. And you just named it some or data or G something else, and add to project. Then next.
It's asking input.
You just skip it. You just next and do the finish. Yeah. After you are having an empty module, you just delete all the things from there, and you just copy that code.
Yeah.
From previous one and paste it here.
Control V.
And paste it here.
Yeah. Module bit or this is pure bit.
Did you paste it? Then after save that, it will show some.
Yeah, just a second.
Okay, fine.
Bit or this or bit. ఏదైతే అది రా మనం చేసింది ఆర్ అని మోడల్ క్రియేట్ చేసింది జస్ట్ గివ్ మీ a second.
Yeah.
Yeah. Now
save that.
Save it, right? Control S. Control S.
Yeah, we have saved that.
Okay. And then in the implementation directory, you are having two files. Did you see there?
Yeah.
In that.
Then we have selected that file.
Yeah. Then right click on that.
Set as a top module.
Set as top module. It will ask you the
Okay.
warning and just choose yes. Now synthesize that.
Yes.
In case of any RTL views are open, you just close on that, because sometimes it does not get updated.
Mm-hmm. It's not, we are not getting those on the left side in the process bit, or no process is running, it's showing.
No process is running. Whether no process running, and in that you are having a synthesize option is there now.
No, we are not getting that option.
Whether
Synthesize.
you are whether you are in the simulation mode or implementation mode.
Implementation.
Implementation. Just choose the process and layout and load default layout.
It's a default layout only.
Default. Yeah. Choose again.
Okay.
Yeah, we have done that, but it's not coming.
Whether now you are getting that processing window, the synthesis view RTF schematics. Hello.
Yeah.
Yeah.
Now are you seeing that synthesis option, implementation options?
No,
Actually,
still not
what are the
coming.
options are there?
Design utilities and check syntax.
Design utilities and check syntax. But if you choose the module, definitely it will get into a synthesis options. So whether you are seeing that same options here, did you see the screen?
Yeah, we are seeing the same options.
Same option. And fine, you just choose the module. That means which is your top module, that only will shows the options.
Mm.
You just choose on
Just a
that.
sec.
Yeah, fine.
Icon of the.
Still, it's not showing.
Actually,
For the other one also, it's not showing now.
other one is not showing.
No process is running.
Which one is your top module?
R.V.
R.V. R.V.
Yeah.
You just change that name into some other name. R is a primitive name.
Okay. How can we change the name?
Actually, whether you have to create a same similar to the text document, just create it again,
File.
or else go to the project directory and
New.
no. What I am saying is, you just remove that. You just remove all the modules inside that project directory. In the left
And
hand
this
side,
file is
yeah.
or dot we have to save it. It's not saved. It's saved. Star is showing. Star means it's not saved.
Okay, fine. Actually, just removed it from the implementation path.
Yeah, removing it.
Just
Right click.
right click on that, remove that modules. That's all. And close.
Confirm.
Yes. Yes. Remove everything in it.
You just remove everything. Now go
Okay.
to the project directory
అదే ఫీల్డ్ కాక కొత్త ప్రాజెక్ట్ ఓపెన్ చేయలేదు. ఆ ప్రాజెక్ట్లోనే డిఫరెంట్ మాడ్యూల్స్. Just a second.
Okay.
I removed everything. Empty.
You just minimize and go to the project directory.
Yeah.
And in that you will find the Verilog file that you have been created. You just see that here I have created 4 files, so just own on that, and you just renamed here.
Yeah.
And your module name also have to change. It must not be a primitive name.
Okay.
So better practice is to you have to choose the text file, the Verilog file name and the module name must be the same one.
Actually, I think it was not saved. I couldn't see anything in the folder. I can only see the previous AND gate that I did.
Okay. Then you have to create it again, or else you just renamed it. And in the case of that,
That also we just removed, right? We can see that again.
yeah, you can see that.
సేవ్ అవ్వలేదు.
ఇప్పుడు సేవ్ చేయండి. ఇప్పుడు మామూలుగా చేయి ఇప్పుడు.
Actually, your project directory you create in that directory only you are having that files. But if you save that, definitely it will be there only.
Okay, how come this is still?
So at least in the project directory, what are the files you are having? Just see that in that how many Verilog files are there, except the Testbench files.
Okay.
Okay.
And in that choose any of the one.
File.
సేవ్ కొట్టరా. సేవ్ ఆప్షన్ రావట్లేదు.
అది వేరు కదా, అది డిలీట్ చేసి.
Yeah, we'll try to create the new project and try.
Okay, fine. No problem.
అంతేగా.
After creating
నాన్ స్ట్రెస్ పెడతారు.
that, you are having an empty view.
Yeah.
From the project, you just choose a new source,
Yeah.
Verilog module, and write your module.
ఇలా కట్టాలి. ఇక్కడ కింద నొక్కు. యా, నెక్స్ట్ ఫినిష్. ఫైల్. ఓకే.
టెక్స్ట్ ఫైల్ ఇది చేసాను ఇందాక.
అదేగా.
సేవ్ కదా. సేవ్.
body.v. The same. Save. Okay. It's not showing anything after we typed everything and we saved in the different directory,
Okay.
but it's not showing anything.
Not showing anything. That means whether it's in a new project or
New project.
okay, fine. Whether you are having this window.
Yeah.
Now, currently you are in this window, or you created the project and you are having that in a project window.
We are in the project window.
In the project window, that means
Test.
it will shows like that, or you are having like that window, that empty window.
First we got the empty window, then I went to file and new.
File new. File new. Actually, if you are doing this one, it will not add the project to your current directory. So what you have to do means source, sorry, project add source.
Okay.
Project add source. Add source.
Mm-hmm.
And you have to add the file, that Verilog file, after saving that.
Yeah, this one.
It will show the Verilog file and you just add it here.
Yeah, added it. Yeah, I got something like that.
Okay.
Okay, right?
Yeah. Add source. Then you're having number of Verilog files are there, means you just choose the top module among that.
Uh-huh.
And it will ask you whether which is a association of all or implementation or simulation alone. You just choose the all. In the case of Testbench, you have to choose that it is a simulation.
Okay.
Then
we choose all only.
Yeah, you have to choose the all only because it's a design field.
Or bit.orchid.v and we are not getting all those in the. It's just showing design utilities and check syntax.
And now also you are not getting any options.
But we got console, like two messages in console. One is analyzing Verilog file, the folder name into the library, and second one, project management, phrasing design hierarchy completed successfully.
The same thing only I'm also having. But whether you are having that symbol like that, that means a chip symbol in near to that project name.
No.
Where empty, that means you are having a empty window like that. Manual compile order.
Yeah, we have like this.
Just
but it's not showing.
That means manual compile order in the sense you are having a tick mark like that. We aren't having any tick mark also in that. Okay.
Without the tick mark, we are having that.
Okay. Without the tick mark, you are having that project name alone.
File.
That Verilog file name.
Yeah.
Right click on that. Yeah. What are the options are there?
Right click and.
What are the options are there? You just say.
Same thing that you're having.
The same thing. Okay. Just choose the manual compile order.
Manual compile order. Okay.
In that, you just choose the click.
Yeah.
Now whether it is showing that.
Yeah. It's showing.
The synthesis option. Yeah, fine. Synthesis it.
Synthesize. Failed.
Failed. What is the error?
The top module has not been specified. This can happen if no source have been added to the project or if using manual compile order and have not entered the name of the top model in the top model field.
Yeah, fine. So compile order.
Okay, I got one idea.
Set as stock module what? Design properties.
Hmm.
Down.
So the module will write the bit underscore or, right?
Yeah, bit underscore or.
So we can write it, or we need to write the one that we have been saving, like
The file name was different and the
That's not
module
a
name is
issue.
different.
That's not a issue. If it is same, it is okay. It's a best practice for you. But in the case of different name, that's not an issue. It will synthesized. No problem.
oh, run now.
No, I'm not going to run.
No, synthesis failed.
The same error will
Run failed.
exist.
Yeah.
So better you just close the file, close project, and do the same thing again.
File.
File, close project.
Oh.
Now choose a new project
Mm-hmm.
and choose your name, and just you just choose a evaluation platform. In that, choose the same board, Spartan 6 XP 601 evaluation platform, and press
Yeah.
next and finish. And then what you have to do means project,
Project
add copy of source,
as add copy of source.
and afterwards you just choose a file that you already created now in that directory.
Okay. Okay.
You just choose a file,
Okay.
and
Just
after
out of curiosity,
you are copying that file. That's all. That is the meaning.
okay.
Okay.
Then adding source file window will shown, and in that you are having that correct Verilog file, and the association must be all, and the library must be work.
Okay.
And choose
Now
OK.
we need to
Source, add source, right?
Add copy of source. Project,
source
add
or
copy of
project.
source. In that project, under the project tab, you just choose add copy of source, not source.
Okay.
Add copy of source, and it will pop up a window, and you just choose your project, that Verilog file.
Yeah. Open.
Yeah, open it. And again,
All work.
window is
Yes.
closed.
All work.
Yeah,
Behavior all work.
all work. Yeah, which is a default one. So you just choose that and click OK.
I'm getting the same thing.
Same thing, error.
Yeah.
Whether you are getting that HDL compiler 1845 unlocking Verilog file, then info project management parsing design hierarchy completed successfully.
Yeah, I got that one. But after that, when I click on that, the file, I'm not getting all the stuff.
You are having only two options.
Yeah.
Yeah.
Which is not a top module. Is that right?
No.
Yeah. Set as top module, no?
Yeah.
Okay.
Whether it is disabled or enabled.
No, it's not showing.
I mean, like, We can click on it.
Yeah.
Enabled only.
Yeah, but there isn't any process going on after clicking on it.
No, actually it is automatically set a stop module. That's all. There is no processor running. So you just right click on that and choose a set a stop module. But in my
I
case
did.
already it is default chosen as set a stop module. So it is disabled on my PC. But for you, it shows only the design utilities and syntax na. DHX syntax.
Yeah,
So you just right click on that and choose a set a stop module.
I did, but it is not showing anything.
And the same thing only you are having. No processor running. Under
Yeah,
that you are having design utilities and that.
yeah. I'll redo it again once more.
Actually, for redoing, that's what we did. Did you reset that layout? Load default layout.
Yeah.
But there's also the same issue.
Mm-hmm. No,
Mm, hello.
yeah, yeah.
Yeah. So still you are seeing that same window. Okay, fine. Choose a simulation.
Just a second. I just created a new one. I'm
Okay,
trying
okay,
to do it.
okay, 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 fine.
Project new source.
Project new source.
New source. Verilog test.
Yeah.
Verilog module, right?
Verilog module, not Verilog specification. Because specification is a test bench.
And file name.
Yeah.
Okay.
And choose next.
Next, finish.
Mm.
Okay.
And
Now delete everything and just copy that one thing, right?
yeah.
But in this one, actually what's happening is the module name is different. I mean, like in the file.
Module name in the sense that's not a problem. But in that case, you may see the name of that project. That is the Verilog file.
Yeah.
Yeah.
So if I write the same thing, then I think it won't be a problem over there.
That's not a
I'm
problem.
just
But it will
thinking.
show the two different modules. That's all.
Okay.
But the name must be different. That Verilog name.
Yeah.
The file name must be different. That's all.
So module input 7:0, A comma B.
Output 7 is to 0 y.
Mm-hmm.
Then assign y equal to A or B. Then end module.
Yeah. Yep. And now synthesize, right?
Yeah. Now synthesize it.
And now I got the synthesize.
Okay.
Do you want to save the changes that you have made to the yes?
Which one?
No, it's just asking me the simple thing. I mean, do you want me to save that file or not? Just press
Yeah.
yes.
fine.
Running synthesis.
Now it is showing the option.
Yeah.
Okay.
I think the error was the module, and after that we are writing a name, right?
Yeah.
That name should be matching the directory that we are creating.
No, not like that. Here, if you are saying.
But once I put that thing, then it started running. I mean, like it showed all the things, and it became the top model, the three dots thing.
Okay, fine. So after synthesizing, just view the schematic, RTL schematic, and
It's still synthesizing. I mean, like.
okay.
Okay, I think it's done.
Oh, fine. Open the schematic view.
No. It just changed it to advanced HDL synthesis. Optimizing. Yeah, it's changing again. XLST successful. Completed successfully.
After the green check, you just open the view RTL schematic once the synthesis is completed.
View RTL schematic. Yeah.
Now, if you are seeing the inputs and outputs, it's 8-bit wide.
Yeah, A 7:0 and B 7:0 and Y 7:0.
So inside that you are having a single OR gate. And if you are seeing the synthesized summary,
just can you how can we open it? Double click.
Double click on that.
Okay. Yeah.
It will automatically elaborate that module. Now you see the OR gate inside that box.
Yeah.
So if it is a multiple modules, then it is complicated to view all the modules. But in case of single modules or simple modules, it is easy to view and analyze whether you are getting the correct logic gates inside that. In case of processors which is having multiple states, so like this, if I am choosing means it is very much complicated to that functionality. See, view the functionality. Only thing is we are able to simulate and we are able to verifying the design constraint.
Okay.
Okay, fine. So now if you are seeing the simulation, you are having simulate that module and A and B of 8-bit wide and you are simulating that. You are getting
your voice is low.
I can't hear your voice properly.
If you are simulating that module, then you will get a 8-bit result. As you know, if all the inputs are 1, then I will get 8 ones in my output.
Okay, I'm just trying to simulate it.
Okay, just try to simulate that.
Right. ISM simulator, elaborate behavior, simulate behavior, right?
Yeah, simulate behavioral model, that's all.
Ravi.
అదే రావాలి రైటింగ్ అది చేసాం కదా
Simulate behavior model. Elaborating.
No.
Yeah. We got the same thing.
Yeah, now force the value.
Force. Right click. Force constant.
So for 8-bit, so choose the 8-bit value. So 1001.
Oh.
second input.
How much you are giving?
8-bit value.
0 0 1 1 0.
We are not getting that force constant. It's deselected.
Deselected.
Yeah, where we need to change?
Actually, from the simulator window, you are having three options now: A, B, and Y.
Yeah.
Yeah.
In that, right click on
Right
it.
click.
Select this.
But whether the wave is shown?
Yeah, we got
Yeah,
it.
we got it.
Yeah.
You're keeping one
Binary. We can give any values,
Yeah,
right?
we can give any values. So in that you are having number of options are there: hexadecimal, unsigned decimal, signed decimal, octal, ASCII. So you just choose any binary or hexadecimal or unsigned decimal, not signed decimal. So just give that, and maybe some 8-bit value, in the sense up to 255 we are able to enter. So 220 is I am giving. So it will automatically convert to binary. So that's not a problem.
Okay.
And after entering values for A and B, you just simulate it and find whether you are getting a correct output.
Yeah. 1, 2, 3, 4.
Only? Hello? 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 Hello?
Yeah, hello.
Hello? Can you hear me?
Yeah.
Yeah, fine.
Yeah.
Did you get the output?
We kind of. Yeah, we got the output.
If you are seeing that output, means we know 1 or 0 is 1, and 1 or 1 is 1, and 0 or 0 0. That means both the inputs are 0 means 0, and if any of the input is 1 means the output will be 0 or 1.
One. Yeah, I got it.
Yeah. Okay. Fine. So if you are defining a multiple bit width means you have to use the that square bracket.
Okay.
Okay. And I have to use the another variable. Here it is a width. Instead of that one, we are choosing width is my variable. So I have to declare initially. So
Oh,
what you are doing means module adder the same thing, sum a and b, and parameter width equal to 7, because which is a variable, and wherever I declare that hello,
where are you adding the width to 7?
that means wherever we are using that width, in that it will automatically assign to value 7.
Okay.
Whatever variable you are indicating, that variable will be assigned to that constant value.
Okay. Okay.
Okay, so instead of that, because some of the programs we are constantly changing the width, so in that case we are using that parameter.
Okay.
For example, if I am designing a multiplier and I have to increase the width for 8 bit to 16 bit, then I will automatically change this 7 to 15. So it will automatically
15.
created the input width from 15 to 0 of a comma b, and output of 15 to 0 of sum, and assign sum equal to a plus b, means automatically the sum is assigned to 15 with 15, that means 16 bit wide sum.
Okay.
So likewise you have to do, for example, and in the same case you just for the or module itself you just rename it,
Uh-huh.
and you just choose the parameter, and you just choose the width equal to 15, and inside the 7 you just choose as width. So now I assigned width as 15, so total inputs and outputs are assigned to 16 bit wide. So wherever I declare that width, then automatically it changes to 16 bit result. Hello, 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 hello.
Hello?
Hello, can you hear me?
Yeah, I think we have a connectivity issue over here.
Yeah,
Our
fine.
Wi-Fi
Yeah, it
Okay,
just resetted.
okay, fine, no problem. So here, if you are seeing that program, I declared a parameter, that means a variable called width of size 15. So now I synthesized, and if you are seeing that synthesized module you are having,
Okay, I think the video, we are not getting the video part.
you are not getting.
I'm not able to, yeah, I'm not able to see the screen.
But my screen is on share only.
Yeah, but we, actually the video is stuck at 7:46.
Okay, fine. Wait a minute, I will pause and share again.
Okay.
Now, did you see?
No.
No.
Can you reconnect one more time?
Yeah, fine. Now?
No, it's still stuck at 7:46.
46. Okay, fine.
I think we have a network problem.
Yeah, I think so, because here it is showing only one attendees. Hello?
But still the screen is same.
Because it shows in my window it is only one attendees, that me one alone, and it is not
Yes.
showing you. I think that's a problem. Hello? Hello? Hello.
Yeah.
Now
We
you are
got
seeing,
your.
I think so. Yeah, fine. Now you are seeing the screen.
Yeah.
Yeah, fine. So just remove it and rerun all. And here, if you are seeing, I have to declare the parameter. So parameter and WD equal to 15. And here I am declaring as WD. So it will automatically assign that WD as 15. So wherever I assign that parameter.
So we'll get a 16-bit line now.
Now you are getting a 16-bit.
Yeah, just give me a sec. I'll.
Okay, you just try yourself.
అది మళ్ళీ మొత్తం క్లోజ్ చేసేయాలి.
Now if you are seeing that you are having 16-bit wide or
Parameter space WD.
Parameter. Can you show the program?
yeah, parameter WD. So yeah, you just rename that and you just create your own variable name.
Is it WD is
With
is a user-defined function, right? We can use
yes,
any other thing.
that's a user-defined variable.
Okay. Yeah. Sorry. Very good.
Yeah, it's okay, no problem.
Now we need to save this again and.
So we just edited the program. Now what we need to do? Just file and run, or
No, you just rerun, save that. Control S.
Okay. I think
And
first we need to delete this.
again, you just close the RTL view because the same thing will open on there.
Yeah.
So,
Yeah, we got this.
and if you see the RTL schematic, it will automatically assign to 16-bit wide.
Yeah, just give me a second. We're not done. Yeah. Yes.
No, idira. Exit over.
No.
It's not assigned.
It is implementation.
Now we need to do implementation and synthesize the tool, right?
Synthesize.
Synthesize it, that's all. Right click on that, rerun all, that's all.
Yeah.
Okay.
Actually, sometimes the old view only shown on that window and it will not get updated. So that's not an issue. So if you are seeing that simulation, in the case of it is not updated, and in the simulation you will see the actual size.
Okay.
It's still synthesizing.
Okay.
Advanced HDL synthesis. So after synthesizing, then?
After synthesizing,
Just view the RTL.
just view the RTL schematic.
View RTL, right?
Yeah.
Yeah.
Okay.
And whether it get updated, that means the port.
Yeah, it is updated.
Yeah.
Then
if you are simulating means you are getting the 16-bit wide result.
Okay, we can add that 15-bit line and we can check the 15-bit target thing.
Yeah.
Simulate behavior model.
Yeah, okay. So this is just an explanation of
That parameter. Because
Yeah, just parameters.
if I want to declare, change my variable size, that means which size of input and output buses, then I have to declare like that.
Okay.
In the parameter.
Mm-hmm.
Because inside the logic, the same thing only there. So without changing the functionality, if I want to increase the width or decrease the width means, then this is the only possibility that you have to use the parameter function. That means use a different variable.
Okay.
So afterwards, and then module port connection. So we already saw that. That means in your top module, you are declaring some port, and in the same order only you have to declare the child module.
Okay.
Okay. So here, if you are seeing that signal A and B are inputs, in the same order only I have to declare GF3 and GF1. And next only is my output, and the output will be signal C and signal D. So likewise, we have to declare that.
Huh.
So next one is the behavior model. So shall we see on the next class?
Sure. Yeah.
Yeah, fine. So you just practice by yourself, and in case you are having any issues, you just let me know. Okay.
Yeah.
Okay.
Yeah, fine. And whether you are understanding my classes.
Yeah, we are.
Yeah, we are.
Okay, fine. If you're having any doubts and issues, you just ask me. Okay.
Sure,
Okay.
definitely.
Yeah.
Okay.
Yeah, fine. Thank you.
Sure.
Thank you.
Yeah.